Good afternoon and welcome to today's Matinee at the S Squared Cinemath. Today's feature presentation is the factor ladder. In the first video on factoring, we used the factor tree to find the prime factorization of different numbers. And at the end of that video, I mentioned another method using a ladder because it is very versatile. In addition to helping us write prime factorization and greatest common factor and least common multiple, we can use it in our work with adding and subtracting fractions especially. And so let's begin with our first application. We will show how to find the greatest common factor of a pair of numbers using the factor ladder. And we're going to use, for this example, the two numbers 24 and 32. So our first step is to write the two numbers side by side on the top rung of the ladder. And then we will start by factoring out a common factor. It does not have to be a prime factor. It can be any common factor that you recognize between the two numbers. I'm going to start with 4. So we write the common factor to the left of the ladder, and then on the rung next to that, we're going to put the missing factors. So 24 divided by 4 is 6. And 32 divided by 4 is 8. And we're going to continue this process of pulling out common factors until 1 is the greatest common factor between the numbers on the rung. So now we look at 6 and 8, and they have a common factor of 2, so we'll write the 2 underneath the 4, and then inside the ladder on the next rung, we'll put 6 divided by 2 is 3, and 8 divided by 2 is 4. And now we look at 3 and 4 and we see that they don't have any common factors other than 1. So once you reach 1 on your factor side, you know that you are finished. And so to get the greatest common factor, we simply take all the common factors on the left side of the ladder and multiply them together, giving us, in this example, 8. Therefore, 8 is the greatest common factor of 24 and 32. The second application we're going to look at is finding the least common multiple. That is the smallest number that both 24 and 32 divide into evenly. You'll see in a few minutes that this becomes very useful when we're looking for least common denominators of fractions. So we already have our ladder set up and we have everything we need. To find the least common multiple, we're going to take the product of the greatest common factor with the remaining factors. And one way to remember this is to draw an L around the greatest common factor, the common factors, and the remaining factors, and therefore we can get our least common multiple by multiplying all of those together. In this case, we get 8 times 1 is 8 times 3 is 24 times 4, giving us 96. Therefore, 96 is the least common multiple of 24 and 32. Our third example of the ladder is prime factorization. Using the same example that we used in finding the greatest common factor and least common multiple, we are now able to write the prime factorization of both 24 and 32. we see that its factors are 4 times 2 times 4. And so, writing those, we will break down the two 4's into 2 factors of 2 for each of them. And we end up with 32 is 2 to the 5th power. The prime factorization of 32 is 2 to the 5th power. And now we will present some of the really cool features of the ladder that the factor tree does not lend itself well. I bet you're already convinced of how useful the ladder is, but I do have a few more applications to show you. The next application we'll look at is simplifying fractions. Suppose we are asked to simplify 45 over 120 in its simplest form. We begin by writing the numerator, 45, and the denominator, 120, on the top rung of the ladder, and then we proceed to pull out common factors just as we were doing before. The most obvious factor is 5, so let's pull that out. And 45 divided by 5 is 9. 120 divided by 5 gives us 24. As a little aside to see how I was able to determine the missing factor of 24 quickly, let's take 120 and instead divide it into 12 times 10, because we can see easily any numbers that is a multiple of 10 is easily divisible by 10. And then we can break down the 10 into 2 times 5, because 5 is the factor that we're factoring out. And we regroup the 12 and the 2 together to get 24 times 5. Developing this kind of flexibility with numbers is a very useful skill to have in your toolbox. Okay, that's the commercial. Now let's get back to our problem. So we have 9 and 24. So far we have broken down 45 1/20 to 9 24. 9 and 24 have a common factor of 3, and so we'll pull it out. 3 goes into 9 3 times, and into 24 it goes 8 times. Now we're at the point where the greatest common factor between 3 and 8 is 1, and at that point we know that we have our simplest form of our fraction. So 45 1/20 simplifies completely to 3/8. Application number 5, finding the least common denominator of fractions for addition and subtraction. Now remember that the least common denominator of a pair of fractions is really just the least common multiple of their denominators. Suppose we want to add 3/8 plus 7/20. Now, we know that in order to add or subtract fractions, we do need to have a common denominator, because the number of pieces in our whole has to be the same in order to be able to add these fractions. We don't necessarily have to have the least common denominator. Actually, the easiest common denominator to find is just the product of the two denominators. So we could easily use 160 as our common denominator to add 3/8 and 7/20. But in order to be more efficient and not have to deal with such large numbers, we're going to find the least common denominator. So let's put 8 and 20 on our ladder, and The most obvious common factor between 8 and 20 is 2, since they're both even numbers. So let's just pull out a 2, and we are left with 4 and 10, which again are even, so we can factor out another 2, leaving us with 2 and 5. And now the only common factor between 2 and 5 is 1, and therefore we are done, and we are ready to find the least common multiple. Remember that we make our L shape around the factors on the left, the common factors, and the factors that are on the last rung. And so the least common multiple, which in this case we're calling the least common denominator because we're dealing with an addition of fractions, would be the product of 2 times 2 times 2 times 5. 2, 2, 2, 5, giving us a product of 40. Now the next slide will show a very cool feature of the ladder. We are going to be able to easily write equivalent fractions for 3/8 and 7/20 using the common denominator of 40. So now I have set up the addends for our addition of the two fractions vertically because it is easier to find our equivalent fractions that way. And now going back to the ladder, notice that the factor that remains under the 20 of 5 tells us that that's the missing factor to multiply by 8 to get 40. And so using the special form of 1, 5/5, because we know that multiplying 3/8 by 5/5 is not going to change its value, it's just going to look different. We get 15/40 for that addend. And then the factor remaining on the last rung under the 8 tells us the missing factor for the second fraction. We have to multiply 20 by 2. And therefore we have to do the same operation to the numerator to get our special form of 1. So 7 times 2 is 14. And now we are ready to add the two fractions. Adding the numerators, we get 29/40. And since 29 is prime, this sum is in simplest form, and we are done. Thank you for watching today's Math&A at the S Squared Cinemath. Now you can practice the new skills you have learned, and now you understand why I believe it's prime time to cut down the factor tree and build this beautiful ladder. See you next time.